Hello, I am Ida Maria, and I am talking on behalf of the groups 13 and 14. We are here today to give you an overview of the greatest banking system that any of us had ever developed before. But first of all, I'll briefly introduce to you our amazing team. Lauri was our product owner. He was the one making all the important decisions about the functionality of the system and was always able to provide a quick and clear answer when the rest of the team got stuck. In addition to that, he also participated in the backend team's work. Our architecture owner was Davi. He managed all the diagrams and models of our system and also created the architecture report. I took on the role of the Scrum Master, so I did my best on keeping an eye on the overall working process and making sure everyone knew what they needed to do. I also participated in the front-end team's work by designing and developing some of the pages. Einar worked on the backend team and was often the one we could turn to with any technical questions. Karl also worked on the backend team and actively participated in important discussions about the system. Rasul was our front-end team wizard, and he was always willing to explain the CSS and HTML magic to his less experienced team members, mostly to me. And finally, Ekaterina was also part of the front-end team and helped with the design and final video montage. Now let's move on to the actual demo of our online bank. To get an overview of how it works, let's all put ourselves in the shoes of Jane, who just got back from a trip to the USA with her friend Mary. During the trip, Mary bought a few museum tickets for her, and now Jane wants to pay her back. She opens the bank application and tries to log in. As she just got home and her fingers are still cold from the below zero temperature, she accidentally inserts the wrong password. Luckily, the system notifies her of this. On the second try, she manages to log in successfully with the correct credentials. She can't remember Mary's account number by heart, but she knows she has made transactions to her in the past, so she just opens the transactions page and finds Mary's account number in the transactions history. She can simply copy it from here, and that's one problem solved. The next obstacle is that the museum tickets were bought in the States using dollars, but Jane usually manages her money in euros. She would hate to spend time on trying to calculate the correct sum, so she is grateful for one tiny extra feature that our system provides. She opens her account settings and simply changes the currency to USA dollars. Now she can simply click New Transaction in the header and insert all the necessary information. Mary's account number, which she copied from the transactions history, the amount, which in her case would be $35, and the description, which is museum tickets. As you can see, under source account, we can see that her money is now managed in USA dollars. She simply clicks create and is notified of a successful transaction. If she now goes back to the transactions page, she can also see the $35 transaction made to Mary Lake. Just as she is about to log out of her account, her husband John runs into the room and says that he really quickly needs to borrow 30 euros from her. Jane says it's okay, and so John opens his own account and goes to the transactions page. He clicks Generate Transaction Code and inserts the correct amount, which in his case is 30 euros, and a description, which is just quick loan. He clicks Generate, and a transaction code is generated. Now all he has to do is share this code with his wife Jane. Jane, in her own bank application, simply enters the transaction code he got from John and clicks Confirm. A new, comfortably pre-filled transaction form is opened for her, and all she has to do is click Create. As we can see, the 30 euro that John required are shown here in dollars because the account current default currency was previously changed to USA dollars for Jane. She clicks Create and is notified of a successful transaction. Again, if she opens transactions history, she can see her most recent transaction to John, and also John, if he opens his bank account, he can see the $30 transaction coming from his wife Jane. Now Jay can go and happily log out of the banking system and go about her day without any further worries.
Hi, I am Taavi, the architecture owner for our group, and I will give a high-level overview of the architecture. We decided to create a web application using the ASP.NET Core framework. As required, we used the model view controller pattern, and we also have a locally running relational database where we keep our data. Here is a simplified diagram with the most important parts. The bottom layer is the model. Here we have domain classes such as transaction, user, and account. Sometimes data is passed to views, and since different views require different data and might have some specific validation requirements, we also use view models, which are based on the domain classes but are usually smaller and tailored to specific views. There are repository classes, which put and get data from the database, and then there are services, which handle things like logging in, processing transactions, and so on. The middle layer is the controller. This is what the user is manipulating, and this decides which views to show and passes data to views, again in the form of these view models. And finally, in the top, we have the view. In our project, they are a mix of C# code and HTML. These are translated to HTML by ASP.NET, and the result of that is what the user sees in their browser. This has been a slightly simplified view because under the hood there are lots of ASP.NET features that we are using. For example, the framework takes care of mapping the domain classes to database tables, binding HTML form fields to our class fields, and vice versa. Also validation logic, we just have to annotate our fields. It also helps us with routing logic. We just have to specify the pattern of how a route is passed and follow this structure when we create and place folders and classes. It also helps with authentication and authorization, and as said earlier, translating our views to HTML. I myself am also not fully aware of everything, since the framework is huge and I had no knowledge of it prior to working on this project. Next, I will speak of the data model. The most important classes are the user. This has the username and password that one can use to log in, along with contact details. Users also have an associated status. When a new user is created, they have a pending verification status. Once an admin approves the account, they are verified. If the user asks for account deletion, they are pending deletion. They have the status pending deletion, and if the admin accepts, then they are deleted. We use roles for authentication. We currently have just client and admin roles. An account is a bank account with a balance. A user can potentially have multiple accounts. A transaction is the movement of money from one account to another, but it also includes C transactions where the admin is considered as the sender. To enable transaction cancellations, we have a status field. When a transaction is submitted, they have the pending status. Once they are processed, they are done. If the user wishes to cancel a transaction, it becomes pending cancellation, and finally, if an admin accepts, the transaction becomes cancelled. There is also a currency class. A user can specify in which currency they want to see their account balance in. Internally, we are doing transactions in euros though. And finally, we also have the transaction code. This is a short code the user can request to be generated for them. It can then be shared with others who can use it to avoid filling out all the transaction details when creating a new transaction. Here is a class diagram with the most important classes for those who are interested. Here we also feature the view models and the most important ASP.NET classes that we extend. But since this is a data model, we left out views, repositories, services, database seeding, and some other less important classes from this diagram.
Hi, I'm Lauri and I'm going to be talking about the technology we used and some difficulties we faced. The most important part of the development of a good application is to choose correct technologies to implement it. Before choosing all technologies, we decided that it should be a web application. Our team members were proficient mainly in two languages, Java and C#. We decided to use C# out of these two because we had one developer who is currently working as a .NET developer, and more of the backend team was familiar with it. On the slides you can see the main technologies we used. Using the .NET Core framework allowed us to easily implement the frontend part with ASP.NET Core. For the database, we needed something that did not need a lot of time to set up, so we chose SQL Server for the database. One of the biggest potential problems we saw before doing the system was keeping a database up to date between all members of the team. .NET Entity Framework offered us the solution we needed, because it is very simple to keep database up to date between different environments, using migrations. The framework choice allowed us to use code-first approach. In code-first approach, you make the main class at the beginning and then annotate with suitable annotation. After that, you allow the entity framework to do its magic and generate proper migrations. In the end, you just need to run those migrations and you have a database in the correct state. That helped us to prevent potential headaches. Our team was divided into two, backend and frontend team. Because of the nature of ASP.NET, there were some challenges how to connect the frontend with backend and who should do it at all. Everyone had a part to do there. Frontend team made our basic design, all those the views, and backend worked on the business logic. In the end, the frontend views were converted to the correct format for the ASP.NET framework by the backend people, since it requires some backend knowledge that the frontend might not have had. We also faced some difficulties. Everyone on the team were 100% familiar with the technologies we chose, so they needed some time to catch up and learn about them. The more experienced developers, of course, helped our other team members to catch up, and so everyone quickly started to do their work. We had some problems with the issues, and some of them were clear enough in the beginning, since they were created quite quickly. I didn't update the issues quickly enough, since I was the product owner. When Olu notified us of our requirements changed. The multiple counting wasn't in the lecture slides in introducing the project. But I guess that's just agile. Because of the issues being late, it led to some confusion and last-minute refactoring to keep users and their accounts separate. So the users, as you saw before, are the actual users and the accounts are bank accounts that hold money in them. In the end, these two were the main issues we faced, and they weren't that hard to overcome. Overall, we are happy with our teamwork and the application itself. Thank you for listening to our presentation about the best mock banking application ever.